All right, today we are doing absolute value. This is actually a review of what we did in Chapter 3. I will talk about some of the issues we had in Chapter 3, and hopefully we can fix them this time. So when we're looking at absolute value, what could I put inside of the absolute value that would make this a true statement? Yes? 5 or negative 5, because the absolute value of 5 is equal to 5, right? 5 equals 5. And the absolute value of negative 5 in that statement, the absolute value of negative 5 is 5. So absolute value really means distance from 0. So if I'm talking about, here's negative 5 and here's positive 5, if I were to measure the distance from negative 5 to 0, the distance is positive 5 units. That's what absolute value is, distance from 0. So what about the next one? So we said that our absolute value could be 5 or negative 5 to make that a true statement. Jamie?
There's nothing you could put in there to make it.
There is nothing we could put in there because no value will give you a value of negative 5 after I take the absolute value. If I put negative 5 in here, it does not equal negative 5. It is 5, right? This is not a true statement. If I put positive 5 in there, the absolute value of positive 5 is 5, and 5 is not equal to negative 5. So there is no value that will ever equal a negative. And that therein is the trick. So no matter what I put in there, in that absolute value, it could be very complicated, like x squared minus x over x squared plus 7x plus 10 is equal to negative 5. What are you going to say?
There's no solution.
No solution. Now we're very clear by probably March you'll be able to do that simplify that expression. But right now you have no idea what that means. So really, whenever you have, even if you knew what to do, we would still say no solution. Yes?
When you say 5, x equals 5, x equals negative 5, could you just put plus minus?
Yes. We can write plus or minus. Okay, so if I have an equation, right, that's the same thing. That overall value of n plus 1, really we're looking for the overall value in the absolute value. Has to equal 5. So we know that it has to equal a positive and also a negative. Okay? So if I put that back in, does everybody understand why we branch it off into two equations? Because the overall value of this, it doesn't matter what's in there, it has to equal a positive 5 and a negative 5. So we just take that original equation and we branch it off into two parts. Now we subtract 1 and I get n equals 4. I'm doing the same thing here, n plus 1. I subtract 1, n equals negative 6, and my solution is negative 6 or 4. So is everybody remembering to branch? Yep. Now, the big problem before, well, we'll get there, never mind. All right, so you have an absolute value problem. I want you to pause it, and I want you to solve this. We are branching off into the two equations. Pause the recording. All right, so we have our absolute value. We branch it off into two equations. I'm not just branching, I then have to solve for x. Okay, the two equations, notice this part, this, and this is exactly the same. What changes is the 15 and negative 15. So I'm going to add 3, x is equal to 18, add 3 to negative 12. So my solution is negative 12 and 18. Okay, and we can check that. We should be able to check that. Mentally or, physically, you can actually write it down. Negative 12 and negative 3 is what? Negative 15. What's the absolute value of negative 15? 15. Is 15 equal to 15?
Yes.
Yep, and then we do the same thing with the other one. 18 minus 13 is 15, and the absolute value of 15 is what? 15. So, all right. So when solving absolute value, this is the problem we had last time when we were doing chapter 3. We have to isolate the absolute value before we branch it off. So we do not branch here. How do I get the absolute value alone? Mike? We are subtracting 7 from both sides. And then, once my absolute value is alone, I set it equal to plus or minus 25. So 2x minus 3 equals positive 25, and 2x minus 3 equals negative 25. This should be an or in here. Okay, what would I do first?
You add 3 to both sides.
And we get 2x equals 28. Divide by 2. You should be doing it yourselves right now. Equals 14. I'm adding 3. Adding 3. Property of equality. 2x equals 28. Divide by 2. And x equals 14. What did I do? Yeah, that's wrong. That's because it should be 22. And x equals 11. And it should be negative. And boy, so my answer is negative 11 and positive 14. Okay, questions? I'm actually going to pause it for a minute. All right, you can check your work here. And let's try the next one. So, Nicole, what would I need to do first here? Remember the rule?
You would have to distribute it.
No, we do not distribute. We have to isolate the absolute value. We never distribute into absolute value. That is the golden rule. Write that in your notes. That was another big problem. People were trying to distribute into the absolute value. So we got to get the absolute value all alone. So what do I need to do to get it alone?
You subtract by 3.
No. Next to, when I have something like 2x, next to means multiplication. So the inverse of being next to it is what? Dividing. Both sides by? 3. Okay. Now my absolute value is all alone. Please write these steps. And now I can branch. Does that make sense? We always isolate the absolute value. Don't distribute it in. Get rid of it. Divide it out. And now we have x minus 4 is equal to positive 6 or negative 6. Subtract, adding 4 to both sides. Adding 4 to both sides. And you should have x is equal to 10 or x is equal to negative 2. Okay? Remember, never distribute into absolute value. Never distribute into absolute value. There's one thing that will make it wrong is when you start doing that. Okay, questions. Last problem, putting it all together. Why don't you pause this one and try and do it on your own? All right, so what do I do first? Let's go with Maddie.
First off, you are going to add this 7 to both sides.
Adding 7 to both sides. And then?
And then you want to divide both sides by 2.
Good. And then we are left with x plus 1 equals 11. Branch it in.
Yeah, branch it into 2.
And x plus 1 equals?
Positive 11.
And
Negative 11.
Good. And we have another way that we can write that. I'm going to just show you really quick afterwards. Okay, and then we subtract 1. And we get x is equal to 10, or x is equal to negative 12. So I put that into our and I get negative 12, comma 10. Are there any questions? Okay, so Elise had asked, can I just write plus or minus? Absolutely. When you are here, Max, can you guys stop talking? Thanks. When you're here and you have it isolated, you may, just to lose the absolute value, you can do this. Oops, forget the branching. Do this. X plus 1 equals plus or minus 11. And then, well, it's really basically the same thing.
Yeah, it's the same.
X plus 1 equals positive 11. X plus 1 equals negative 11. Subtract 1, subtract 1. So it's basically the same. Okay, so don't worry about that. All right. So that is our lesson for the day. Any questions? Yes.
I don't see why you would want to do this, but could, instead of making the non-absolute value part positive and the non-absolute value part negative, could you make the absolute value positive and negative?
No.
No?
No, we're not doing that. Because, well, it already is negative and positive, basically. Right? Because there's two values that fit in there. That's why we have to account for the outcome to be a positive and a negative. That already exists. All right, that's the end of the lesson.